Right, city kids. Right, city kids. All right, on a more serious note, let's get to problem 9-124. As the city planner of Wright City, you're responsible to report information to help the Board of Supervisors make decisions about the budgets for the fire and police departments. The board has asked for a report with answers to the following questions. Each grid unit in the figure at right represents 1 mile. For fire safety, bushes will be cleared along the perimeter of the city. What is the length of the perimeter? Include all of your calculations in your report. So this one is probably, I would say, the most tricky problem of today. It is really hard because when you look at the triangle that is given, you can see that we are not allowed to count diagonals on a grid. So these sides it's not going to work. But we do know that this side here is 1, 2, 3, 4, 5, 6 units. Now, we don't know what the other sides are because they're diagonal. So you can see what I did was I drew in right triangles with my yellow marker. So now we are able to find the missing length of these two sides of Wright City, which means we can find the perimeter. So let's take a look at this triangle first. Its legs are 2 and 3. Now the length that we're missing is that hypotenuse, right? Because it's right across from the right angle. So we have to plug 2 and 3 in for A and B. So A squared plus B squared equals C squared. So we're doing 2 squared plus 3 squared equals C squared. All right, 2 squared is 4, plus 3 squared is 9. That gives us C squared. 4 plus 9 gives me 13. Now, 13 is not the missing length. 13 is the missing length squared, remember. So to unsquare, we'll take the square root. And the square root of 13, if we put it into our calculator, is going to be, it's going to be an irrational number. So we're going to round to 3.6. It's actually, when you put it into the calculator, it's going to give you 3.605551275. But like I said, let's just round to 3.6 because we don't want to deal with all of those digits. That's a lot. All right, now I'm going to go back here. I'm going to erase this, right? Because I know that my missing side length now is 3.6 or about 3.6 units. All right, now we're going to do the same thing to find the other missing length of Wright City. So I'm going to look at this triangle now. So I have, again, I'm given the 2 legs because this is the right triangle. This is the hypotenuse. So we have a length of 3 and a length of 1, 2, 3, 4. So I'm just going to plug that into the Pythagorean theorem. And remember, either of those, it doesn't matter which goes in for A, which goes in for B, as long as we're not plugging in for C, because C is the hypotenuse. So we're going to have 3 squared plus 4 squared, that equals C squared. Well, I know that 3 squared gives me 9, plus 4 squared is 16. That equals c squared. 9 plus 16 gives me 25. Now remember, 25 is not the length, it is the length squared. So to unsquare, we take the square root. And the square root of 25 is 5. So in this case, this hypotenuse equals 5. Remember, the hypotenuse is that diagonal side of the triangle. So this length is going to be 5 units. All right, so once you make sure that you have all of this work shown, we'll move on. I'm going to erase it though, so I have room to put more work. All right, so now that we've done that, we can just add these numbers up easily to find the perimeter. So it says to include all of your calculations in your report, so that's what I just erased and what I am about to do. So we're going to do 3.6 plus 5 plus 6. That gives me the perimeter, right? Because for perimeter, I just add all of my sides. So 3.6 plus 5 plus 6 is going to give me about 14.6. Now remember, we're measuring in miles. So we want to say 14.6 miles. And really, we should change this equal sign to equals approximate, because remember, we rounded on this 3.6. So we're going to say it's approximately 4.6 miles, that perimeter. All right, now let's take a look at part B. Part B says, some people say that Wright City got its name from its shape. Is the shape of the city a right triangle? Show how you can tell. All right, so now that we have all of the lengths of this Wright City triangle, we can plug them into the Pythagorean theorem. And that's a squared plus b squared equals c squared. Remember, c is the hypotenuse, which is the longest side. It doesn't matter which, as far as the other two go, it doesn't matter which we put in for A or B, as long as I'm getting that 6 in for C. So I'm going to do a squared. I'll put that 3.6 in, plus 5 squared equals 6 squared. 3.6 squared is going to give me 12.96 plus 25 equals 36. All right, let's go ahead and add that 12.96 and 25. So 12.96 plus 25 gives me 37.96. Ooh, yikes. So if this is going to be a right triangle, this side needs to be equal to this side. So this side would have to be 36, or this side would have to be 37.96. So in this case here, we do not have a right triangle, so this is not a right triangle. And again, that's because 37.96 is not equal to 36. It's close. I mean, it's definitely close to a right triangle, but it's not going to work for this one. So that's all we have for problem 9-124.